Look up at the night sky. Among the thousands of stars, a few immediately stand out. They burn noticeably brighter than all the rest. Today, we're going on a journey to the 5 brightest of them, and we'll start with the most modest one of the 5. Let's go. Our first stop is Vega. It sits in the constellation Lyra, just 25 light-years away from us. By cosmic standards, that's practically next door. But if you were to fly there on a regular airplane at 560 miles per hour, the trip would take about 30 billion years. So we're gonna speed things up a little. There she is. Vega is an A0 class star. Its surface is scorching at around 9,600 Kelvin, nearly twice as hot as our sun. Its mass is about 2 solar masses. It shines 40 times brighter than the sun. Vega is significantly larger than the sun, too. Its diameter is about 2.04 million miles, which is 2.36 times wider than the sun. If you were to put Vega in place of our sun, Earth would become a very inhospitable place. Vega is a relatively young star, roughly 455 million years old. Fun fact, about 14,000 years ago, Vega was the North Star, and it will become the North Star again in roughly 13,700 years, when Earth's axis completes its slow precession cycle. So the star we currently use for navigation is really just a temporary landmark. Take a look at its shape. Vega spins at an enormous speed, one full rotation every 12.5 hours, while our sun takes nearly a month to do the same. At its equator, the rotational speed exceeds 143 miles per second. For comparison, the sun's equatorial rotation speed is just over a mile per second. Because of this, Vega is slightly squashed. Its equator is 19% wider than its poles. Like a ball spinning so fast, it's on the verge of flying apart. A little more, and the star would simply tear itself to pieces. No confirmed planets have been found around Vega yet, but there is a dust disk surrounding it, a hint that planets may exist there, or perhaps once did. Let's take a look at what Vega looks like from the nearest planet to it, about 2.3 light-years away. We're on the nearest planet. From here, Vega looks quite large and bright. Let's keep moving. Next up is Arcturus. It's in the constellation Bootes, about 37 light-years away from us. Even on the approach, you can tell something here is very different from Vega. Arcturus is an orange giant. Its surface is much cooler than Vega's, around 4,300 Kelvin. Its mass is close to our Sun's, about 1.1 solar masses. But its size? Arcturus has puffed up to 25 solar radii. Its diameter is 22.1 million miles. And despite its lower temperature, Arcturus shines 170 times brighter than the Sun, simply because it's so enormous, and its total surface area radiates a staggering amount of energy. Arcturus is one of the oldest stars in our neighborhood. It's about 7 billion years old, nearly 2.5 billion years older than the Sun. And it's racing through the galaxy in a completely different direction from most nearby stars, and much faster, about 76 miles per second relative to us. It clearly has its own unique story. Let's put Arcturus in place of the Sun in our solar system. Arcturus would stretch nearly halfway to Mercury's orbit. A neighbor like that isn't cozy, it's catastrophic. Temperatures on Earth would exceed 1,100 degrees Fahrenheit. And here's what Arcturus would look like from our planet. No confirmed planets have been found around Arcturus, but SpaceEngine came up with something. Let's take a look. Oh, 6 planets. Let's fly to the first one. This one is just a scorching ball of heat. The average surface temperature is over 36,000 degrees Fahrenheit. Let's try to get a view of Arcturus from the surface. Actually, we can't. The planet's atmosphere is way too thick to see through. All right, let's check out the second one. This ball is a bit less scorching. Surface temperature is around 2,370 degrees Fahrenheit. This planet's orbital period is 36 days. Let's land and watch the sunrise. What a stunning view. A little ominous, but stunning. Now let's enjoy the sunset from the far sixth planet. A year here lasts 1,059 Earth years, and the average temperature is over 960 degrees Fahrenheit. Yeah, that's beautiful. On to the next one. Our next stop is Alpha Centauri, and I'll say this up front, there's a lot more going on here than it might seem. Alpha Centauri is not a single star. What we have here is a triple star system in the constellation Centaurus. The two main stars, Alpha Centauri A and Alpha Centauri B, orbit each other with a period of about 80 years. And somewhere off to the side is the third star, Proxima Centauri, a small, dim red dwarf. And this is the closest star system to us, just 4.37 light-years away. If Voyager 1, the fastest spacecraft we've ever launched, were headed here, it would take around 70,000 years to arrive. Let's approach the main star, Alpha Centauri A. It's a G2 class star, almost identical to our Sun. Its mass is 1.1 solar masses, and its diameter is about 1.26 million miles, just 1.22 times wider than the Sun's. Surface temperature is around 5,790 Kelvin. Age, 5.3 billion years. Essentially, this is our Sun's older brother. A little bigger, a little brighter, a little older. If we swapped out our Sun for Alpha Centauri A, almost nothing would change. No confirmed planets have been found around Alpha Centauri A or B just yet, but Proxima, that small, dim little star, has something interesting going on. A confirmed planet, Proxima b. Let's fly over and check it out. Proxima b. Orbital period, about 11 Earth days. And it sits in the habitable zone, at a distance where liquid water could theoretically exist. That said, Proxima regularly fires off powerful flares that scorch everything around it. But the fact alone, a planet in the habitable zone of the star nearest to us, is pretty intriguing. Let's see what the stars of this system look like from Proxima b. Proxima Centauri. And Alpha Centauri A and B. Just like from Earth, they appear as a single star from here, though noticeably larger. As for a sunrise or sunset, unfortunately, that's not happening here. Proxima b is tidally locked to its star, just like our moon is to Earth. One side of the planet is in permanent daylight, and the other is in permanent night. Let's continue our journey and head to the largest star in our lineup. Next up is Canopus, and right off the bat, one important note. It's much farther away than everything we've seen so far, 310 light-years from us. It's in the constellation Carina. In the northern hemisphere, it's nearly invisible. It sits too low on the horizon. But in the southern hemisphere, it's the second brightest star in the entire night sky. Now we're talking about a completely different scale. Canopus is a yellow-white supergiant, spectral class A9, luminosity class 2. Its mass is about 9 solar masses, and its diameter is 61.4 million miles, making it 71 times larger than the Sun. Surface temperature is around 7,400 Kelvin, and it shines 16,000 times brighter than our Sun. Compare that to what we've seen before. Vega was 40 times brighter than the Sun. Arcturus, 170 times. Canopus, 16,000 times. And despite being 12 times farther away than Sirius, it still blazes in the sky nearly as bright, simply because it's monstrously powerful. If you replaced the Sun with Canopus, its surface would stretch out to roughly the orbit of Mercury. Earth would have a rough time next to a sun like that. Its surface would heat up to around 4,080 degrees Fahrenheit, and there'd be no watching the sunrise in real life. But in SpaceEngine, of course we can. By cosmic standards, Canopus is a fairly young star, only 25 million years old, and it's the youngest star on our list. Fun fact, NASA uses Canopus as a navigational reference point for interplanetary probes. It's so bright and distinct that it's ideal for determining a spacecraft's orientation in space, a natural beacon at the edge of our corner of the galaxy. No confirmed planets have been found around Canopus. SpaceEngine found a few. Let's take a look. We're on the nearest planet. Orbital period, 112 days. Surface temperature, around 4,136 degrees Fahrenheit. Canopus is rising. It takes up a massive portion of the sky. Even from here, it's clear. Nothing could survive this close. On the far planet, the temperature is a bit lower, minus 247 degrees Fahrenheit, and it takes 3,041 Earth years to complete one orbit around Canopus. From a distance of over 48 billion miles, Canopus doesn't look quite so terrifying anymore. If you didn't know that that ball in the sky is 16,000 times more powerful than our sun. On to the last one.
And finally, Sirius, the brightest star in the entire night sky. It's in the constellation Canis Major, just 8.6 light years away from us.
And once again, it's not a single star. Sirius is a binary system. The main star is Sirius A, white and blazing bright. Its mass is 2 solar masses, surface temperature around 9,940 Kelvin, and it shines 25 times brighter than the sun.
Here's an interesting thing to consider. Remember Canopus, the one that shines 16,000 times brighter than the sun? And Sirius is only 25 times brighter. So why does Sirius look brighter than Canopus in our sky? Simple. Sirius is 36 times closer. Canopus is monstrously powerful, but distance takes its toll. Put Canopus where Sirius is, and it would blaze like a second sun, visible in broad daylight. Fun fact, Sirius was incredibly important to the ancient Egyptians. When it first reappeared on the morning horizon just before sunrise, after several months of absence, it meant the Nile flood was coming. The Egyptians built their calendar around it. The brightest star in the sky served as their natural clock. And that small, faint dot right next to it, that's Sirius B, a white dwarf. It was once a star about 5 times more massive than our sun, but it has already lived out its life. It shed its outer layers and collapsed down to roughly the size of Earth. Yet its mass is nearly equal to the sun's. Think about that. The mass of the sun packed into a ball the size of our planet. A teaspoon of Sirius B's material would weigh several tons. Sirius A and Sirius B are more than just neighbors. They're bound together by gravity, slowly orbiting each other. One complete orbit takes about 50 years. The distance between them is constantly changing, from as little as 8 astronomical units to nearly 32.
That's roughly the same range as the distance from Saturn to Uranus in our solar system. A tiny white dwarf and its brilliant companion, a cosmic dance that has lasted for millions of years. No confirmed planets have been found around Sirius, and SpaceEngine didn't generate any either. So let's watch Sirius A set from the surface of Sirius B. The final sunset of our journey, Sirius sinks below the horizon. Five stars, each one unique. The young, fast-spinning Vega, the massive, ancient Arcturus, the close-knit triple family of Alpha Centauri, the monstrously powerful Canopus, and the bright, familiar Sirius. Every one of them has its own story, its own temperature, its own fate. And all of this, just 5 dots in our night sky. Ones you can see simply by looking up. Let us know in the comments whether you enjoyed this video and what you'd like to see next. And don't forget to like and subscribe. It really helps the channel grow. See you next time.